Hello everybody. This will be another series of videos about a variable frequency drive or a variable frequency inverter that I started to build this morning, and since now I have finished my capacitance decade box, it's time to move on to the next part of my project. So this, just like a quick presentation, this will be a rather dumb inverter. It will be a push-pull inverter with an oscillator, with an SG3 3525 push-pull oscillator with DC4422 MOSFET drivers, and it will have as a main component this baby boy. This is, I don't know, maybe 1.5 kilowatt, maybe 2 kilowatts worth of transformer. It is center tapped. As you can see, it has 24 volts, and here on the other side there is the center tap, and also it has 12 volt and another 12 volt leg of the winding, which is also center tap. Here all of the windings on the primary meet there. This box was part of my previous variable frequency drive, which I have burned. Man, I have burned the hell out of it because I have chosen the wrong transistors, well, actually MOSFETs. Now I'm using, oh man, I don't know if you can see it, IRFP 4568. They are 150 volts MOSFETs, and they withstand 171 amps. So this was my, oh wait, it's kind of a mess here because I started working and everything is just flying around. This was my panel of my X inverter, which I will have to adapt somehow into the new one. These were the precision knobs for, I think this was for duty cycle, and here was the variable resistor for the frequency, which I have moved, and I made a gearing system, a gear reduction. I made it myself so the tuning of the frequency will be more precise. And so now I have this button, this dial, to tune the frequency. This is the voltmeter. It measures AC from these two sockets. This is a circuit breaker, an automatic fuse. When something goes wrong, bam, it goes down and cuts down the power to these sockets. These were my ventilating fans for the MOSFETs. They were wrongly placed. The MOSFETs overheated, and the back EMF from this transformer destroyed them. Well, it was going to destroy them anyway, because the MOSFETs were rated at, my previous MOSFETs were rated at 40 volts, and the back EMF from the transformer was 47 volts when idling. And at 50 hertz, no, wait, it wasn't even 50 hertz, it was about 20 hertz or so. Imagine what will happen if I raise the frequency at which the transformer works. And back here there are a couple of automatic fuses for the 12 volt part. I only found 5 fuses alike. This one is just the same fuse as the others, only it has different button construction and placement, but they are all rated at 20 amps, so 20, 40, 60, 80, 100, 120 amps worth of fuses here. Okay, these were my 24 volts terminals which connected to the batteries, and now it is time to revive this baby up. And so I thought of a different way of placing the MOSFETs, so I don't use separate radiators. On the previous build I used separate CPU radiators, well, heat sinks or however you want to call it, and I had long wires to the MOSFETs, which was a very bad choice. The wires overheated, they had inductance and capacitance to them, and they generated a whole set of problems, which ended up in burning my transistors. So this is a neat radiator from a DVD player. I have purchased from the flea market, and I have got it out for parts, of course, because it wasn't working. And as you can see, I have marked the wait, let me show you. I have placed the transistors first, so I can adjust the distance between them so it can be equal, and then pressing with my finger, I drew a line, well, a contour like this, so that I know where each and every transistor stands, and then with a fine tip marker I marked the center of the hole of the transistor, and then I drilled wait, I think it was 2mm holes as pilot holes for the next hole, for the next drill bit, and drilling with a smaller diameter drill enabled me to have a smaller I don't know, error threshold. So I drilled them with 2mm drill bit, and then afterwards I enlarged the holes with 4, I think, yes, 4mm or maybe 3, I don't know for sure. Yes, 4mm holes. And now all I have to do is, these are mica insulators. I have to place them with thermoconductive paste on the radiator and on the transistor's backside, And when it will be finished, my idea was this. After attaching the transistors, I will put radiators, these big CPU radiators, on top of it, on top of this long radiator. Also, I will mount these uh, radiators or heat sinks with thermoconductive paste and fasten them with something. I think it will be thick copper wire, and add another fan here, so that it will be two fans, one here and one here, so air will move faster through the center of the main radiator. And after that, those two fans that I talked about earlier from the previous inverter build will be removed and placed on top of these huge radiators. Maybe I will buy another set of fans. That is, if the electronics store opens up in between uh, uh, Christmas and New Year, and I will put four individual fans, so that I will keep my MOSFETs cold as ice. Okay, what else? I will have to rearrange. This is my huge this is my huge capacitor bank. These are 1000 microfarads at 63 volts. Low impedance capacitors. They are for stroboscopes and all kinds of flashlights. The ones that you find in photo cameras, flashlights. I will have to tie everything together as a mock-up, and then redesign the whole box and so forth, and run over to the hardware store while it is open and buy me some new plywood sheets and reassemble a new box with a new shape. Also, what I wanted to show you is these copper strips. I have 6 of them. 3 of them will be connected to 6 transistors, gate drain source, and I will not solder any more wires to the pins of the transistors. Instead, I will bend them like this. I don't know if it sees. Oh, wait. I will bend them like this. 90 degrees. One pin is bent 90 degrees to the left. The other one is unbent, and the last pin is bent 90 degrees to the right. And this will enable easy access with the crimping pliers from the sides. And I will crimp